Hello everyone, my name is Adrian Arfire. I work with Airparif in Paris, France, and I will be presenting to you today our work in scaling up local sensor evaluation and also give you a preview into a recently launched project that aims at integrating low-cost sensing with our regulatory network and modeling framework. For those of you who don't know Airparif, it is the Paris Region Observatory for Air Pollution. It was created in 1979 as an independent NGO accredited by the French Ministry in charge of the environment. It gathers in its board all air quality stakeholders, the state, local authorities, economical agents, NGOs, and experts. And its missions are monitoring the air quality for regulatory purposes, understanding air pollution phenomena, and assisting stakeholders by providing information, collaborating on action plans, and fostering innovation. 3 years ago, Airparif launched its innovation accelerator called AIRLAB with the stated objective of going further and faster in reducing air pollution in Paris and its surrounding region by facilitating and coordinating innovation on technical, social, and behavioral aspects, and by identifying new levers through exchange and experimentation. AIRLAB seeks to evaluate technological solutions, to develop the economy and employment in this fast-growing sector, and also to promote the international profile of the concerned regional players. The AIRLAB ecosystem is composed by institutional actors, large enterprises, startups, very small and small to medium enterprises, the research community, and the civil society. Since its founding, AIRLAB has launched 22 innovation projects or experimentations. It has tested 97 solutions and currently has 80 members, 85% of which are SMEs and very small enterprises. The main topic of my talk is how we are scaling up low-cost sensor evaluation. Our motivation is seeking the scale-up is the ever-increasing demand from both AIRLAB partners and the larger community for information on the performance of microsensors currently on the market through an independent and recognized evaluation. What we had come to realize in the years leading up to the first edition of the challenge is that our previous MO of performing evaluation as demands came in, based on individual demands, was reaching its limits. Our metrology service was reaching its bandwidth limits for processing these demands sequentially. It was very difficult to make comparisons between evaluations made at different moments in time, and also it was difficult to assess the adequacy of a solution for other applications than the one included in the initial demand. Our solution was to change this way of operating and to challenge manufacturers through periodic systematic evaluation campaigns. The challenge format we built helped reduce the strain of the metrology service outside of the challenge campaign period. The parallel evaluation allowed comparisons between products and enabled us to connect sensors with their possible usage cases by considering more criteria than metrological performance. The AIRLAB Microsensor Challenge aims at linking sensors and their use cases represented through categories. I'll come back to this notion later on. Determining and providing information on the most relevant sensors by category of use, establishing a snapshot of the technological state of the art of a rapidly evolving field, both in terms of sensing technology and algorithms, and supporting innovation to improve sensors. The AIRLAB Microsensor Challenge is a periodic evaluation campaign in realistic conditions of commercially available microsensor-based measurement products. The challenge is not a certification tool. The AIRLAB Challenge is not an exclusively Airparif venture. Its consortium includes multiple partners from other air quality observatories, industry, research, and international institutions. The main two documents governing the challenge are the rules and the protocol of the challenge. The rules of the challenge define the participation conditions, the modalities for selection, testing, and ranking, the protection of intellectual and data property, as well as confidentiality, and the withdrawal conditions. The challenge protocol details the evaluation criteria as well as the associated testing protocols. Both documents are freely available online on the AIRLAB website. I won't go into the details of this calendar, which is from the 2019 edition, but I would like to use it to illustrate the unfolding of the challenge process. After the call for application is launched and submissions are received, a first jury decides which submissions are accepted. This goes through a pre-verification period when the operation, communication, and data recuperation of the devices are checked. A second jury is convened after this stage, which decides which candidates can proceed to the full evaluation phase, which in 2019 edition took 4 months. A final jury then verifies and validates the evaluation results, deciding also if any awards can be awarded for candidates in specific categories. So, what are these categories? There are 8, and we have grouped them in 3 classes depending on the environmental domain. For outdoor air, we consider applications that target complementing monitoring networks, raising awareness, or mobile vehicular applications. Similarly, for indoor air, we have the monitoring and awareness raising categories, and also applications for piloting air quality inside buildings. Finally, we consider citizen air categories for devices that target personal exposure assessments and personal awareness raising. In this case, we are talking about devices that are meant to be portable by an individual throughout his or her daily routine. These are the evaluation settings that were used in the last edition of the challenge. For the static outdoor air, we use one of our regulatory monitoring stations. For mobile outdoor air, we equipped one of our vehicles. All indoor air evaluations were made inside our metrology lab. And finally, for the citizen air, we equipped a backpack that was carried by Airparif volunteers. A lot of effort was made in streamlining the data acquisition from these heterogeneous sources of data through to data processing and generating the deliverables. 40 evaluation criteria were used, which are grouped into 5 major classes and are weighed depending on the usage category. For example, a sensor running in the outdoor air awareness category will have a higher weight placed on ergonomics than accuracy, while for one running in outdoor air monitoring, it will be the other way around. The challenge deliverables look like this: a concise 2-page summary of the results, with the first page giving the general review by the jury, a statement of the best performing category, the main sensor features, and the radar chart summarizing the main performance results. The second page provides the detailed results and the company information. Although still dominated by French candidates, the last edition of the challenge is relatively more international than the first one. And you can see here also a breakdown of candidates by country and by the submissions by environment category, mobility, and target pollutants. 130 devices were tested, generating 560 time series and more than 53 million data points. All the results for both the 2018 and 2019 editions are freely available on the AIRLAB website. When using these results, one should keep in mind the following scope and limitations. The main goal of the challenge is to create a large and publicly available information repository for the benefit of all potential users. The results of the AIRLAB Microsensor Challenge are published for information purposes only and do not constitute a guarantee of product performance. A correct interpretation of the challenge results should take into account the inherent limitations of such an evaluation format, like the limited evaluation time or the site choice for the outdoor evaluation. The main take-home messages after the 2019 edition are the following. The tested solutions show an adequate technological maturity for indoor applications. Developments are encouraging in outdoor air. but the technology is not yet ready to meet regulatory requirements. The solutions targeting personal exposure assessment or mobile applications need further improvement. All evaluated sensors present at least a satisfactory level in terms of ergonomics, and very importantly, not all solutions are really low cost. Finally, as promised, here is a sneak peek into our current flagship project for integrating low sensor measurements into our monitoring network. The project, launched earlier this year and financed by the Ile-de-France region, is called Measurements and Perceptions, and it targets the deployment of a total of 600 sensor units on post office buildings, postal trucks, and courier bikes that will measure NO2, PM1, PM2.5, PM10, CO, and ammonia. Its vision is that of integrating this data with our regulatory network uh, and our modeling framework in order to obtain higher precision maps with higher resolution and the ability to zoom in on micro-local phenomena. One of the main challenges of this project is that of QA/QC, quality assurance and quality control, which due to the high number of sensor units cannot be performed in a traditional way. Complete pre-deployment evaluation of the sensor units is not possible, and traditional validation of the measurement data is also impossible. As such, we will need to implement state-of-the-art algorithms for anomaly, anomaly detection, fault detection and event detection, but also for on-the-fly calibration. I thank you all for your attention and will be very happy to take your questions.